Today we'll go through an example of sending ERC20 from L1 over to L2 Optimism. For this example, we'll say that this ERC20 token exists only on L1. When we send this token over to L2, what actually happens is that the representation of this ERC20 is minted. This ERC20 token on Optimism is an extension of ERC20. This token is called Optimism Mintable ERC20. When we send ERC20 from L1 to L2, this is what happens. The ERC20 token is locked inside a contract called L1 Standard Bridge. This L1 Standard Bridge calls the contract cross-domain messenger, and the cross-domain messenger sends a message over to L2. On the L2 side, the contract L2 Standard Bridge is executed, and it's going to mint this OPERC20, Optimism Mintable ERC20. So basically, when we send ERC20 from L1 to L2, we are locking the ERC in the L1 contract called L1 Standard Bridge, and on the L2 side, we are minting a new token. When we send ERC20 from L2 back to L1, we burn this OPERC20 on L2 Standard Bridge. Once the token is burned, it will relay a message over to cross-domain messenger on L2. Once the message is relayed, we will need to take some extra steps, such as proving the withdrawal transaction and then finalizing the withdrawal transaction. After that is done, we can unlock this ERC20 by calling L1 Standard Bridge. Here are the things that we will cover in this video. We will deploy a ERC20 on L1 and then deploy a OPERC20 on L2. We will deploy L1 bridge on L1 and L2 bridge on L2. Back in L1, we will mint some ERC20 and then send this token over to the L1 bridge. We will mint this ERC20, write a contract called L1 bridge, which will call into this L1 standard bridge. And by doing so, we are locking the ERC20 on L1 and then minting the OPERC20 on L2. On the L2 side, we will check the balance of the ERC20 on L2, withdraw this ERC20, and then we'll send this ERC20 from L2 back to L1. Back inside L1, we'll check the balance of ERC20 and then withdraw this ERC20. In the final part of this video, we'll look at the transaction that finalizes the withdrawal. And then we'll check for token transfers. Okay, so let's start with step 1, is to deploy our ERC20 on L1. So I've created a simple ERC20 contract over here. The only difference is it has two functions, has a function to mint, anyone will be able to mint, and we're going to mint some tokens to our account. This function also has a function called burn, but we won't be using this function. Okay, the other contract that I've created is called OPERC20. To integrate with the L2 standard bridge, we need to extend our ERC20 contract. This contract, OPERC20, is an ERC20 contract that we'll deploy on L2. And it has some extra features that we need to implement. These features are the functions over here. Remote token. This is a read-only function that returns the address of the remote token. Since this token is going to be deployed on L2, here the remote token refers to the token on L1. Bridge refers to the local bridge. When we deploy this on L2, this bridge will refer to the L2 standard bridge. And then we also need a function to mint and a function to burn. So if I scroll down, you can see over here that I implemented the function for remote token, bridge, and I've implemented ERC165 that you can see over here. Basically, it's a function that tells which interface it supports. And the interface that we need to support is ERC165 and Optimism Mintable ERC20. Okay? And the last two functions that we need to implement is a function to mint tokens and a function to burn tokens. And for this example, I made it so that this function mint and burn can only be called by the local bridge. So this will be the L2 standard bridge that can only mint and burn tokens. We will deploy the ERC20 and OPERC20 contracts later. Let's first write some code. So back inside bridge.sol, want to implement a contract called L1 bridge and L2 bridge. These are contracts that will call into the L1 standard bridge and L2 standard bridge. I'll start by declaring some interfaces. Interface L1 standard bridge, and we also declare another interface L2 standard bridge. We will fill out the functions that we need to call later. So next, I'll create a contract L1 bridge, and let's also declare a contract L2 bridge. We also need to interact with the two ERC20 contracts, ERC20.sol and OPERC20.sol. So the next thing that I'll do is declare interface for ERC20. So I'll just copy and paste it here. Interface for ERC20. Okay, let's start by declaring some functions that we need to call inside L1 standard bridge. To send ERC20 tokens from L1 to L2, we'll need to lock this ERC20 inside L1 standard bridge. And the function that we'll need to call is called bridge ERC22. Now there's another variation to this function called bridge ERC20. But if you understand how to use bridge ERC22, then you also know how to use bridge ERC20. So this is the function that we'll be working with for today. On the L2 side, to send ERC20 from L2 back to L1, the function that we need to call is exactly the same. The way it behaves is different, but the function that we need to call is the same. Bridge ERC22. Another way to send ERC20 is by calling deposit ERC22. This function internally calls the same function as bridge ERC22. However, this only works with the contract Optimism mintable ERC20. So in this example, instead of calling this function, we'll be calling this function. They basically do the same thing. And likewise, when we send token from L2 back to L1, we can also call a function called withdrawal2. And internally, it calls the same function as bridge ERC20. And again, this function only works with the contract Optimism mintable ERC20. However, the contract that we're going to deploy is not exactly the same as Optimism mintable ERC20. This is a contract that implements Optimism mintable ERC20. So it's a little bit different, but basically they do the same thing. So for this example, when we withdraw tokens from L2 back to L1, we'll be calling this function, bridge ERC20. Okay, let's move on. Let's start by writing the contract for L1 bridge. What this contract will do is transfer ERC20 from message.sender and then send it over to L1 standard bridge. The L1 standard bridge will lock this ERC20 and then relay a message to mint OP ERC20 on L2. So what this contract is going to do is going to call this function, bridge ERC22. I'll first start by declaring some constants. We'll store the address of L1 standard bridge as L1 OP bridge and the two tokens that we're going to deploy, L1 token and L2 token. On Sepolia, this is the address that we'll use for the L1 standard bridge. Okay, next let's write the constructor. It's going to take in three parameters, address, L1 OP bridge, address, L1 token, and address, L2 token. And then we'll set them. L1 OP bridge is equal to input, L1 OP bridge, L1 token is L1 token from input, and L2 token is L2 token from input. Next, we'll approve the L1 OP bridge to be able to pull tokens from this contract. So say ERC20 L1 token dot approve L1 OP bridge for the amount max type uint256.max. Now I'm not sure if this is the safest or the best way to do it, but for this example we'll just keep it simple. Next, we'll write a function to send this L1 token over to L2. Say function send to L2. For the inputs, we'll pass in the address to send the tokens to on L2. Address, remote, ADDR, and the amount to send, uint256 amount. External. And first, we'll transfer the L1 token from message sender over to this contract. ERC20 L1 token dot transfer from message.sender to this contract for the amount. Okay, next we'll call this function bridge ERC2 on the interface L1 standard bridge. So over here, paste the function. And then I'll say L1 standard bridge, L1 OP bridge dot call this function bridge ERC22. And then for the inputs, we'll pass these. Local token will be the L1 token. Remote token will be the L2 token. 2 will be remote ADDR. Amount will be amount. Min gas limit. I'm not really sure what to put in here, so I'll just put in 200,000. And any extra data to pass over to L2. We'll just send the empty data. Okay, so this is how you would send the token from L1 over to L2. All you have to do is call the function bridge ERC22 on the contract L1 standard bridge. Next, I'll create a helper function so that we can withdraw any tokens that is inside this contract. And this will be a useful function when the tokens are sent back from L2 over to L1. And then once the token is inside this contract, we'll call withdraw to withdraw the token. Function withdraw. Address token, external. And then we'll just say uint256 balance is equal to ERC20 token dot balance of address this. And then we'll just transfer all of it out. ERC20 token dot transfer to message dot sender for the amount val. Okay, that completes the contract L1 bridge. Next, let's write a contract for L2 bridge. The contract for L2 bridge is going to look similar to the contract for L1 bridge. So I'll copy all of this and then paste it here. And then we'll modify some of the parameters and the state variables. On the L2 bridge, we will store L1 token and L2 token. And instead of storing L1 OP bridge, we'll call this L2 OP bridge. This will be the address of the L2 standard bridge contract. And Optimism, here's the address. Okay, and then I'm going to rename these inputs. Instead of approving the L1 token, we'll approve the L2 token and approve the L2 standard bridge. Next, let's modify the function send to L2. I'll rename this to send to L1. What this function is going to do is it's going to send the token from L2 back to L1. To do this, again, we'll need to call the function bridge ERC22. The address of the contract will be L2 OP bridge. The interface that we'll call is IL2 standard bridge. And now, here's the interesting part. On L2, the local token is the L2 token contract. And the remote token, which refers to the token on L1, will be the L1 token. And the rest of the inputs are the same. Okay, the other thing I'll fix is instead of trying to transfer the L1 token, we'll transfer the token on L2. Okay, and that completes the contract for L2 bridge. So now we can start from step 1 to deploy ERC20 on L1. I'll hit Ctrl S to make sure that the contract compiles. Okay, and now let's deploy ERC20 on L1. So I'll click on this deployment tab, and then click on injected provider. First, make sure that we're on Sepolia, and then we'll deploy our ERC20 on L1. So I'll select this ERC20 contract, compile it so that I'll be able to select it over here, and then deploy this ERC20 on L1. Confirm the transaction. Okay, the transaction was confirmed. Here is the address for the L1 token contract. I'll copy this. We're going to need this later, so I'll paste it here. Okay, moving on. The next step is to deploy a OP ERC20 on L2. So to do this, I'm going to switch my network, open my MetaMask, and then under Networks, select OP Sepolia. Make sure that OP Sepolia is also selected inside Remix. And then I'm going to select this OP ERC20 contract, hit Ctrl S to compile it so that I'll be able to select it over here. Then select this OP ERC20 contract. Okay, and to deploy this, we'll need to pass in some parameters. Remote token will be the ERC20 on L1. Paste it here. And the bridge address. Bridge refers to the local bridge on L2. So this will be the bridge, the L2 standard bridge deployed on Optimism. To get the address, I'll select on the bridge contract and then scroll down. And this is the address of the bridge contract. So I'll copy this and then paste it under the bridge input and then deploy the OP ERC20 contract. Then confirm the transaction. Okay, the transaction was confirmed. So here is the OP ERC20 deployed on Optimism. I'll copy this address and then I'll paste it here. We're gonna need this later. Okay, the next step is to deploy L1 bridge on L1 and L2 bridge on L2. So let's start by deploying L1 bridge. We'll switch the network back over to Sepolia. I'll select L1 bridge and then for the inputs, L1 OP bridge, this is the address that we'll need, L1 token, and L2 token. And then deploy the L1 bridge contract. Confirm the transaction, scroll down, and the L1 bridge is deployed. I'll copy this address and then paste it here. Okay, next we need to deploy the L2 bridge on Optimism. So open MetaMask, change the network, make sure that inside Remix we're on Optimism Sepolia, and then scroll down, and then click on L2 bridge, and for the inputs, address of the L2 standard bridge, paste it here, L1 token and L2 tokens, L1 token, and L2 token. confirm the transaction. Okay, the transaction was confirmed. So I'm going to copy the address of the L2 bridge contract and then paste it here. Okay, what's the next step? The next step is to mint ERC20 and approve L1 bridge. So to do this, we'll need to go back to Sepolia. Select Sepolia, open the ERC20 contract, and then we'll mint some tokens. So I'll copy the address of my account, paste it here, and that's mint 1000 token. Confirm. Okay, next I'll approve the L1 bridge. So I'll copy the address of the L1 bridge and then paste the address over here. And for the amount to approve, I'll just put a large number and then hit transact. Okay, we're now ready to send this ERC20 over to L2. So to do this, we'll need to call the L1 bridge contract and call the function send to L2. For the remote address, we'll pass in the address of the L2 bridge contract that we have over here. So I'll copy this, paste it here, and for the amount, let's send 100 token. Confirm the transaction. While we're waiting for the message to relay over from L1 to L2, you can check the status by going to optimism.sepolia.blockscout.com. Here I'm going to paste the address of the ERC20 on L2, OPERC20, and then search for the contract. Then I'm going to click on internal transactions, and you can see that there are some activities here. So this probably means that the message was relayed over from L1 to L2. I'm going to click on the latest one, and you can see over here that token was minted. Back inside Remix, I'm going to switch back over to Optimism Sepolia. Let's check the balance of OPERC20 for the contract L2 bridge. I'm going to copy the address of L2 bridge, and then inside the contract OPERC20, I'll click on balance of. Click on it, and we get 100 token. So what just happened is that we locked our ERC20 on L1 and then minted another representation of the same token on L2. Okay, let's withdraw this token from the L2 bridge contract. Inside the L2 bridge contract, paste the address of the contract and then call withdrawal. Okay, the transaction was confirmed. Let's check the balance of OPERC20 for L2 bridge contract. So I'll copy the address and then paste it into here and then call balance up, and it is now equal to 0. How about our account? Copy the account, and then paste it here, call balance up, and we now have 100 OPERC20. Next, let's send this OPERC20 back to L1. So what's going to happen is OPERC20 will be burnt by L2 standard bridge, and then on the L1 side, our ERC20 contract that is locked inside L1 standard bridge will be unlocked. So to start off with, we'll approve the L2 bridge contract. The spender will be this L2 bridge contract. I'll paste it here, and for the amount, doesn't really matter, so I'll just put in a big number. Confirm the transaction. Once the transaction is confirmed, to send tokens from L2 back to L1, we'll call the function send to L1 on the contract L2 bridge. For the remote address, we'll pass in the address of L1 bridge contract. Paste it here. Now if you want to directly send it back to your account on L1, you can here just paste in the address of your account. But for this example, we'll send it to a contract. So I pasted the address of the L1 bridge contract. For the amount, 100. And then confirm the transaction. When we send tokens from L2 back to L1, there are extra steps that we'll need to execute. These are to approve withdrawal transaction and then finalize withdrawal transaction. So what I'm going to do is we're going to execute the node script that I've shown you in the previous videos. You'll first need to copy the transaction hash for the transaction that we just executed to send token from L2 back to L1. So from my MetaMask, I'm going to copy the latest transaction ID. Back inside my code editor, we'll execute a script that will send the transaction to prove the withdrawal transaction and to finalize it. So the script that we're going to be running is node source index.js. And here's the code. What it's going to do is it's going to send a transaction to approve the message and then to finalize the message. So to execute the script, I'm going to open my README and then first paste the L2 transaction hash. And then we'll execute the script. Okay, the script ran successfully. You can also check the status of the transaction by going to optimism.sepolia.blockscout withdrawal.com. And here's the transaction detail. And if you scroll down, you can see the withdrawal status. You can see over here that the transaction was relayed over to L1. Back inside Remix, make sure that you're connected to Sepolia testnet. So this will be L1. And let's check the balance of ERC20 inside the L1 bridge contract. So scrolling down, I'll copy the address of the L1 bridge contract and then call the function balance up on ERC20. And we now have 100 token inside the L1 bridge contract. And to withdraw this token, we'll call the function withdrawal on the L1 bridge contract. Inside the function withdrawal, I'll paste the address to the ERC20 contract. Paste it here, call withdrawal. Okay, once the transaction is confirmed, let's check the balance of L1 bridge for the token ERC20. Scroll back up, and then here paste the address of the L1 bridge contract, call the function balance up, and we get back 0. For the last part of this video, let's check the transaction that finalized the withdrawal transaction from L2. Inside Etherscan, I searched for my account, and if I scroll down, I see a list of transactions. Here I see a transaction called finalize withdrawal transaction. This is one of the transactions that was executed when we executed the node script. I'll click on this transaction, and if I scroll down, you can see over here that our token was transferred over from the L1 standard bridge contract over to our L1 bridge contract.